Hello, everybody. My name is Masoud Olia, and I'm a faculty in the School of Engineering at Wentworth University. And I'm here again with a problem related to the topic of kinematics of particles. And it's a really simple problem related to constant acceleration, or basically free fall motion. So here you have this problem where you have a balloon and a sandbag dropped from the balloon. Now, the balloon is moving at a constant speed of 6 meters per second upward. So its initial velocity is upward. So that means velocity of the sandbag being dropped is also initially 6 meters per second. It says the bag is released with the same upward velocity at t equals 0 and hits the ground when t is 8. So at t equal 8 is going to hit the ground here. It takes 8 seconds for this to happen. So what are we trying to find? The speed of the bag as it hits the ground. So just about when this bag is about to hit the ground, what is the final speed of the bag, right? And then the altitude of the balloon at this instant. So you have to be careful with this part, altitude of the balloon. Remember, when you drop this, there is a certain altitude here, but the balloon is also moving up. So the balloon has moved up, and we want actually the altitude of the balloon at that instant. So we have to add some other distance to it. So this is what we call a constant acceleration. Free fall motion is a rectilinear motion up and down, right? And acceleration is constant. In this case, since we are dealing with a metric system, acceleration is 9.81 meters per second squared downward, constant acceleration. Now, you guys know that for constant acceleration, we have a bunch of equations that we can use. I'm going to put all three equations that are relevant, or actually two of them are relevant, but I'll put all three of them. So one is the velocity for a constant acceleration can be calculated using the initial velocity plus at. Position is basically the integral of this equation, which becomes S0, which is initial position, V0 plus 1/2 at squared. Okay. And then finally, another equation which actually we're not going to use for this problem is one equation that is also useful, but it depends on the situation. Here you don't have any time involved, so you have the relation between speed, acceleration, and position. Keep in mind that these are equations only valid if a is constant, which is the case here. A is gravitational acceleration. Okay, so let's go and solve this problem. So first, I want to find out how long, in that 8 seconds, what is the altitude of the sandbag in 8 seconds when it hits the ground. So where was it? So depending on where you want to pick your reference, you can pick your reference to be here. So this is your final position, right? And your initial position, if you want to call this S0. So your final position is 0, and S0 is what we are trying to determine. What was the initial position? Or you can pick this guy as the reference and final position S. It really doesn't make any difference. It's up to you. And this is the equation we're going to use. So S is 0. S0 is unknown. And V0, so if we call this positive direction, our initial velocity is 6 meters per second times 8 seconds, right? Plus 1/2. Then the acceleration, you have to put a negative 9.81 times t squared, which is, sorry, 8 squared here. So go ahead, solve for S0 is what I want. So S0, I believe it becomes 265.9 meters if you do the calculations. Now, keep in mind that this guy in that 8 seconds has moved up, because the problem wants you to find actually the altitude of the balloon at this instant, not the distance between where you dropped the sandbag to where it hits the ground. So what happens in 8 seconds, since this is the constant velocity of 6 meters per second, you don't even need the subscripts 0, V0. It's constant, that's the key. When you have constant velocity, position is simply determined by this. So how far this guy goes up is simply 6 meters per second times 8, so 48. So this has gone 48 meters up. So the altitude of the balloon then is S or H or whatever you want to call it. Maybe we should call it H now, right? Of course, the balloon is, now this is the bottom of the balloon, right? And so on. So let's call it H. So this H becomes what? H becomes the sum of these two. So 265.9 plus 48. And that is about 313.9, 314 meters. Okay. And then there is another part to this problem, which is very easy to determine, is what is the speed at which the bag is going to hit the ground. Just before the bag is about to hit the ground, what is the speed? Well, that's where this equation comes in. V equal V0 plus AT. All right. So we're picking this to be positive direction, right? Initial velocity is 6 meters per second. Acceleration is minus 9.81 times 8 seconds. If you do the calculation, you get negative 72.5. Negative just implies that it's pointing downward, so you could show it like this. So just before it hits the ground, it has a speed of 72.5. Okay, I hope you enjoyed this video. As always, I appreciate if you subscribe to my channel and hit that like button. Thank you, and I'll see you soon with new videos.